I've now done so. Welcome, everybody. Welcome to our weekly call. As you will have seen hopefully from my email reminder this week, we're continuing the theme that we started last week around sort of machine learning and related topics. Last week's was sort of presentation of a paper with results, if you will, where the difference this week, I saw what I thought was a very interesting blog post on the AppNix site, which Thymen posted probably about 3 or 4 weeks ago now, I guess, which caught my eye, and he's very kindly agreed to join us this week and talk about that. And if I understood the blog post, this is more about sort of research that's planned rather than has been completed. So maybe there's an opportunity to influence it in some way. So that's going to be the main sort of focus of our discussion this week. No doubt we'll pick up on a couple of other things afterwards, but I'll hand over first to Thymen. As I say, you should be able to share your screen should you wish, but let's see if that works, and if there are any exciting technical problems, I'm sure we'll fix those. So thank you for joining, and over to you.
Thank you. I think you can see my screen right now, or at least my slides.
Yep.
Yeah, so today I will be talking about the projects or the ideas that we have at SIDN, the research, the .nl TLD operator, some plans that we have for applying machine learning to, well, further increase the stability and security of our zone, but also the wider internet. So that's what I will start with. So that's kind of a vision or a research agenda that we have come up with. And then the second part of this presentation, I will focus on two projects. One project that we are running for a couple of years now, that's about detecting fake web shops. And the other project is a project we started a few months ago. So I have some results there to share with you, but I'm also open for discussion. So I'm wondering what you think about that project and whether you have ideas. So while I was preparing this presentation, I was looking at my desk, and I see many of you are also working from home. And on my desk, I have plenty of books to lift up my monitor a bit. And one of the books that I have here was the first book that I had to read when I was doing artificial intelligence. And it's a really a big book, and there's a lot of topics in there. And one of the topics, it's actually one chapter that's about machine learning. And within that chapter, there's a single section which is about deep learning. So that was 12 years ago. And I think if you would open the news nowadays, that things are completely different. Everybody's talking about AI, about machine learning, and deep learning in particular. But what is it actually about? I think you all have some clue about this, but nevertheless, I want to put things a bit in perspective, because that perhaps might help the discussion and the presentation that will follow. So AI is about the search for intelligent computers that can solve decisions without any guidance by a human. And that's a really challenging problem that we cannot solve today, and perhaps not within 10 or 20 years. But within AI, there is a subfield called machine learning, which is about data and about extracting patterns from that data. And you can use those patterns to do predictions or make decisions. And a specific technology, a specific way to do that, to extract those patterns, is deep learning. And today I'll be talking about machine learning in particular. Most of the algorithms that we use are relatively simple, so linear methods. Sometimes we do use deep learning, but that's the exception. But first of all, data, machine learning, extracting patterns, is that relevant for the DNS? Is that relevant for a DNS operator, a TLD operator? I think it is, because as a TLD operator, for example, you have a lot of data sets. Of course, your zone file, but there are also active and passive measurements that you can use. You have perhaps some DNS logs that you can use. And there are, of course, ground truth labels that you can use from abuse feeds or other types of data sources. So we think it's relevant to use machine learning, because you can use the tools that machine learning gives you to extract patterns and rules that can increase the security of the DNS. And our approach here is to innovate with machine learning instead of doing the innovation of the field itself, because there are pretty large universities, but also companies like Google, etc., that are way better in investing in the algorithms themselves. So what we try to do is we try to monitor all the papers that come out, see which algorithms, which methods are promising, and then we try whether we can use them for our own purposes. And we do that for ourselves. So our first goal is to make DNL safer, but we also try to collaborate with other parties and publish about the research that we do. So that's also the reason why I'm here. So yeah, like it's in the blog post, there are 3 research topics or research areas that we want to work on the next, say, 2-3 years. So the first research question, that's really follow-up question on the research we're currently doing. So we do a lot of things to detect suspicious or abusive domain names, and we want to get even better at that. So we try to be faster, but we also try to focus on different types of abuse within our zone. And the second research question is about how we can improve our models by collaborating with other parties. So what we often observe is that it's very easy for us to spot strange things. So we have some suspicion that a particular domain name is perhaps abusive, but we don't have the evidence to really prove that suspicion. So then it makes really sense to partner with other organizations. So for example, parties like hosting companies or registrars who have perhaps different perspective on the problem, or with government organizations who perhaps, or financial institutes who perhaps have some other features that you can add to your training data. And the other way how we want to collaborate with other organizations is by adding more training samples to our data set. So as DNL, we only can oversee the DNL domain zone, but of course, different TLD operators have kind of similar data structures, and you can perhaps also add those rows, those data files to your training set, and then make your models more accurate. But of course, that's a challenge because you need to exchange data, and that's a legal issue, that's a problem. So we want to see whether we can do some smart things there. For example, not sharing the raw data, but only sharing intermediate models. So that's the second research question we want to explore. And the third research question, that's something that we haven't really thought about a lot, but what we currently have at SIDN Labs is our own test bed for an Anycast infrastructure, and we run an NTP time service on that infrastructure, but it's really difficult for us right now to monitor that Anycast infrastructure. So we want to explore how we can analyze the data that we got there. So that's really a topic that we haven't really thought about a lot. So those are the topics, the things that we want to do, but we also thought some about how we want to do it. So we want to do it in a responsible way, of course, but what does that mean, applying machine learning in a responsible way? I think you can have lots of discussion about it, but for us, one of the most important things is that we want to have the human in the loop. So that means that our algorithms, they cannot make decisions about domain names on their own. So what we do is we provide our network operators or abuse analysts with a suggestion, but they have to analyze it themselves and make the decision themselves. Another thing that we do is we have a privacy board within SIDN. So that's a board that checks whether a project is appropriate and also asks some challenging questions to me as a researcher, which I think really helps to think about the project that you want to do. And the last thing that we do regarding the human in the loop is that we also use the feedback that we got from our analysts. So we provide them with a prediction, and then they say it's a true positive or false positive, and we use that feedback again to retrain our models. The second thing that I think helps to act responsible is that we try to use the most simple and interpretable models as possible. Because if your model is simple, then you can easily explain why it works and why it doesn't work. And it's also easier to maintain your code, of course. And the third thing that we try to do is we try to collaborate a lot, because by collaborating, you have a different perspective on the problem. You have perhaps also different data sets that you combine, and that helps to model your problem in the right way. And of course, publishing your work is also a way to gather feedback and perhaps also inspire others to do the same. And the last thing that I would like to mention, and perhaps you have some ideas about this as well, is the monitoring the performance of our models. And if you read an academic paper, for example, you see a lot of performance monitoring on a test set. But of course, we want to use machine learning in production, so then you don't have the labeled data to test whether your model still works or whether you need to update it. So that's a challenge, I think. And if you have some ideas on how to solve that, I would love to hear it. So that's the high-level part of the research that we're planning to do within SIDN Labs regarding machine learning and abuse detection. But like I mentioned at the beginning of this presentation, we already do a couple of things. So during the rest of this presentation, I want to briefly mention two of those projects. And the first project is about fake web shop detection. So on this slide, you can see an example of a fake web shop. It's called nederlandwebshop.nl. And as you can see on the slide, the web shop is well designed. There are popular brands out there, and there are also many discounts. So most consumers who will visit this website, they will probably also they will be willing to buy something. But it turns out that this web shop does not deliver. And we have also seen web shops that do deliver, but they deliver cheaper counterfeit versions of the original product. And that's a problem, because consumers, they experience losses, and those losses, they have been in the media quite a lot. On the right side of the slide, there's a screenshot of the Dutch public broadcaster about those losses. And for SIDN, being a TLD operator, that's also a problem, because we don't want people to have less trust in the internet. So we wanted to do something about this thing. And we can actually also do something here, because being a registry, we have a good vantage point. We have the list of all .nl domain names, and we also have some additional data. So for example, we have crawling data, but we also have DNS data that we can use to find patterns that can be useful. So we're running this project for a couple of years now. We started it in 2016. Since then, we have detected thousands of web shops, and we also were able to take most of them down. So I think that's a great success. And another success is that we wrote an academic paper about this project. So I will not go into detail about this project, because some of you perhaps already read that paper or saw the presentation at RIPE. But also for me personally, that was a great success, because it was the first academic paper that I published. So that was cool. So how does this actually work, the fake detector? Well, it's the straightforward machine learning pipeline. So what we did, we collaborated with ICS Cards, which is a popular credit card issuer in the Netherlands. And they provided us with a list of .nl domain names that were actually involved in scams. And we use that as a ground truth data set. And we derive features from that data set. So we use registration related features. So for example, the hour of registration or the email provider that the registrant used to register the domain name. And we also used a couple of infrastructure related features. So for example, whether TLS was used, whether the domain name had an email server configured, these kind of things. And then we split our data set in the training and testing data sets. And we use the training data set to extract patterns to generate a model. And then we use the testing samples to verify whether the model performed. And as you can see on the table below, the precision and recall for the test set was really high. But I have to say that this is a small data set. So it's more of an indication that the model performs and not a really valuable evaluation method. But at least it provided us with the intuition that we could continue with this project. So what we did is we created a tool out of it, and we're running that detector now for a couple of years within SIDN. And as you can see on the table on the right part of the slide, we, especially in 2018, we detected quite a lot fake web shops, and we also were able to took them down. So in that year, we took down 12,000 counterfeit web shops. But the years after, that number decreased, and last year we detected 481 counterfeit web shops. So that's a thing that we're still puzzling what's happening here. It could, of course, be that the people, the criminals that register those domain names, that they are able to pass by our system, or perhaps they started a new business model. We just don't know. So if you have any clue about this, I'm happy to hear that as well. But what we also learned is that it was really important to collaborate with different parties. So ICS was really important here because they had the ground truth data. They could tell us whether a domain name was indeed malicious or not. And we partnered with the registrars because they had more possibilities to take domain names down, because we cannot do that ourselves, or it's really difficult to do it. But yeah, like I said, what we also saw is that the number of fake web shops that we detected decreased. So one of the things that we started to think about was new models, new methods to detect suspicious domain names. So that's the step to the second project. And so here you see two slides, two pictures of two domain names, web shops, websites. On the right part, you see a web shop. And on the left part, you see a page that looks like a page of the Dutch government, where you can sign in to enroll for a COVID-19 test. But as you can see, there are two logos here. So on the left part, there's the logo of the Dutch government, and on the right part, you see logos of, for example, Trustpilot, but also logos of payment providers. So these two malicious websites, you could detect them using logo detection. So that was the motivation for this project. What we wanted to do is to build a tool that could help analysts find suspicious web pages just by looking at the visual aspects or the logos on web pages. So this system, it consists of a couple of components. So what we do first is we crawl all the .nl domain names, and then we take screenshots of those domain names. And we are basically using Selenium for that. We added something here because we wanted to skip duplicates. Some of the pages, some of the domain names, they redirect to the other pages, or you observe the same HTML content on multiple domain names. So we wrote an algorithm there to be able to skip duplicates, and that made our crawler way more efficient. A second thing that we built was an object detection algorithm, and this algorithm, it was based on YOLO, you only look once. And we came up with an algorithm that allowed us to train the algorithm without generating the ground truth data ourselves. So this method is really simple. What it basically does is we have a couple of random screenshots, and we paste a logo somewhere on that page on a random position. And because we know where we pasted that logo, we have the bounding box for the algorithm to train. It's a really simple method, but it worked really well. So that's nice. And then we finally built an annotation dashboard where analysts at SIDN or other organizations can explore the results. I added a few slides of that tool. So it's basically a table with all the results, and you can click on the annotate button, and then the details of a single result will pop up. So here you see the results for SIDN.nl. So there's the screenshot, of course, but there's also some other information that can help the analyst to do the annotation. So for example, the registrant, the registrar, but we can also add data like MX records or whatever you like. And then on the bottom part, there are some buttons that analysts can use to set a label and a status. And then they can just go to the next result in kind of a queuing interface. So that's the system that we built at the beginning of this year. But building a system is, of course, cool, but it's not enough. So we wanted also to verify whether it has added value, whether it can contribute to a safer .NL zone. So for that, we did a study with the Dutch government. And this study consists of 2 experiments. So first, we applied the logo detection algorithm to all .NL domain names. And the goal there was to discover new domain names that are used by the government, but that the government didn't know they existed. So for example, those domain names were registered by a project leader without telling his manager or the IT department that the domain name was actually in use. And the other experiment focused on new domain name registration. And there our goal is to detect phishing attacks. And that second experiment that runs for 2 months now. So I cannot really give you any results there, although we do see some phishing attacks that we find, but it's the number. We're still analyzing whether we were before other detection methods. So I cannot really go into detail there. But what I can do is give you the results about the application of the model to the full zone. And that's the graph that you see here. And we'll start at the right side. So the bar at the right, those are the domain names where our object detection algorithm thought the logo of the government was present, but it turned out that after annotation, the logo was not there. So that's the case in 10K of our results, or in other words, 89% of the cases. So that's a good precision, I would say. And then the second bar starting from the right, those are the benign domain names. So that's the majority. Then we found a little bit over 100 abusive domain names, very few prior 1, and 107 prior 2 abuse cases. So the number here is not that big, as we saw with the counterfeit web shop. Those domain names, they have a higher priority. So they're really good phishing attacks. And we also saw some redirects of domain names that people seem to use quite a lot, or at least based on the DNS data that we have. But we're currently trying to analyze what's going on there. And on the left part, you see that we also discovered domain names that were actually used by the government, but not in the portfolio of the government. And here the numbers are perhaps not that big, but if you compare the numbers with the total set of known government domain names, then we discovered using this tool 70% of the total set that was already in the portfolio. So that's quite a lot. And why is that important? Well, because if you are not aware of a domain name, you cannot monitor it. And you can also not try to improve the security standards of your domain name. And that's the thing that I'm currently researching. So here you can see to what extent DNSSEC is adopted for each category. And the bottom 2 bars here, those are the ones that were already in the portfolio and the ones that were in the portfolio of the government and detected by our tool. And you can see here that the majority of those domain names, they do support DNSSEC. However, the adoption rate is a little bit lower for domain names that are likely from the government and the ones that are definitely from the government. And we see a similar pattern for IPv6 adoption. So the majority of the domain names that were in the portfolio, they already support DNS IPv6 because they publish a Quad A record. But for the discovered domain names, that rate is a bit lower. So this is also important for the government and also for us as a registry, because we want to push the government to use those technologies. We can ask them to implement those technologies, those standards as well. Yeah, so that's what we have currently for this project. And what we learned so far is, well, that visual aspects like logos, they can definitely help to detect abuse. We were not the first who explored this, but yeah, for a registry, it really helps to to detect abuse. It can also help, and that was the other goal, to help your domain portfolio accurate, which is also important, especially for larger organizations. And we also found that there is a very large gray area of unwanted content, and the government is still decided, we are still in the process of what we want to do about that. For us as a registry, it's not really a problem, but perhaps the government wants to do something about it themselves, but that's their part. And the next steps that we have for this project, we want to do a pilot study with an accreditation scheme for web shops, because we see that many of the counterfeit web shops, they also promote things like Trustmark or other accreditation schemes, and perhaps that's also a perspective to detect them. Like I said, we currently monitor the new domain name registrations, and we're also writing an academic paper about this project. So if you have ideas for that, I would like to hear it. And we're also considering to publish the code. And that's something that needs approval, of course, by our management team. And it also will be a small investment from us. But I was wondering whether perhaps you are a TLD operator yourself, or you are in a different position to use this tool as well. So I was wondering whether it would be useful for you, because that really helps to convince the management, so to say. And that concludes my talk. So if you have questions, I'm very happy to answer them.
Fantastic, thank you. So it lived up to the billing as how to use sort of machine learning to improve Internet and DNS security in a variety of ways. So if anyone's got any questions, please either use the Zoom tool to raise your virtual hand or put them in the chat, and we'll come to them in turn. I see Brett and Mark have already raised their hands, as has Peter. So Brett, do you want to kick off?
Yeah, it wasn't really a question, more of it's great work. It's really, really interesting, and I'm very interested to know to know more about it. But in particular, I wanted to address your question at the end, which was, are other TLD operators interested in this? And I think I can safely say that Nominate are always looking for ways to improve the security posture of the .uk namespace. So we would definitely be interested in the code if you were to publish it, if that helps you push that forward.
Brilliant. Thanks, Brett. I'll leave you and Thymen to pick that up offline should you wish. Mark, do you want to come in?
Yes, I do. So yeah, a comment and a question. So I would like to comment that at Microsoft, at least, the problem of employees who register a domain name for a campaign or a project, use it for Microsoft purposes, but without approval or branding, and then abandon it when they're done, used to be a huge problem. So I'm not surprised to see that in .nl, that 17% of the government-looking sites were really not part of the portfolio. This is a problem for any large organization, and we've put a lot of education and policy around preventing it. It's a never-ending struggle. My question was, also thank you for the presentation. I thought it was great. I do hope other registry operators will consider your methodology. Then my question was, you note that you were using this project as a way to work more closely with your registrars. And I was wondering if you could mention more about that collaboration. In my experience, registrars are very cautious about signing up to doing content management work in public, but are frequently very, very good to work with more confidentially. And I was wondering what sort of a relationship that you had with these registrars and what you learned from it. Thanks.
Yeah. Thanks for the question. That's indeed a very valid point. Regarding the counterfeit web shop project, I think we had a benefit there that there was a lot of media pressure. So there was a lot of bad news about those counterfeit web shops, and there was sort of I think perhaps also kind of a marketing way why this was an advantage for the registrars to collaborate with us. But nevertheless, it is quite an investment to work with our registrars. There are, of course, quite a number of registrars that are very willing to work on those projects because they feel the same problem. But in some other occasions, you really have to convince them. And I think our support department, they invest a lot of time in having a good relationship with those registrars. And I think that really helps in this project. And also, I think for the counterfeit web shops, the majority of the web shops, they were registered with just a few registrars. So we didn't have to contact thousands or hundreds. We really had to invest in a relationship with about 10 or so. So that also helped our case.
Great, thanks for the question, Mark. And a reminder, anybody else got questions, please raise your hand or put it in the chat. Peter, you have a question or comment or both?
Yeah, thank you, Thymen. That was really fascinating, and it looks like great research. I would also love to see the code and get my hands on the data if possible. We do a lot of it at DNS Filter, this kind of stuff. We also use machine learning to try and identify deceptive sites in general, particular phishing, but scam stuff as well. We look at the actual code of the site rather than the other indicators that you've been looking at, like the infrastructure and stuff like that. We do whatever. We're not quite doing how you're doing it. So I wanted to say one thing, which is you noticed that big drop off, and definitely the people that run the fake sites become aware of the things that make them stand out and adjust to it. It's you know, it's a business like anything else, and they have dev teams who are working on this kind of stuff. So it requires us to be constantly retraining the model. We do like manual checks on a regular basis, and then make sure that we kind of feed that back into the models to make sure that it picks up the new bits, however it works. So if you haven't retrained it since then, I think that would definitely be the thing. Although I can't speak to what those things might be in the last couple of years, but it does need sort of constant effort. The other thing I wanted to ask was, so you get in touch with the registrars to help get the sites taken down, but there's also other companies out there that do DNS filtering that can you know, help. What I would love to do is compare the list of sites or domains that you've identified with the ones that we have, and see what kind of correlation, what's the overlap. And one of the nice things about the way we're doing it is anything that we haven't seen before that a customer of ours queries, we go off and take a look at and try and classify it. So we get a lot of stuff that's not really seen otherwise, or isn't known as a threat yet. So I'd be curious to see how it compares with your data set as well. Yeah, but anyway, thank you so much for the presentation. It was really interesting. I do a lot of stuff related to what you're doing, so I'd love to talk more about it in the future.
Cool, nice to hear. Yeah, let's have a chat then later on, because yeah, it would be nice to explore some ideas. Regarding the question or comment, we do retrain our fake web shop model. But the numbers are quite low, so it's really difficult to do the retraining now in an appropriate way, because you don't have really enough samples to do the training part. But I think there perhaps the business model might have shifted a bit, because before we were doing anything, it was really cheap for the counterfeiters to just register many as domain names as they could. But now we're taking them down, so then they're losing a lot of money. Because they cannot use those domain names anymore. So perhaps that might also be a reason or an indication that they shift to another business model. So instead of having thousands of domain names, having one or two that they really invest in and care about. So that could be also an explanation, but I'm not sure.
We saw also a lot of actors moved to third-party services. So like Shopify for a while was used, but then Shopify got better at taking those sites down. But like it's the same thing with fake form sites. You know, it was alchema.com and then typeform.com and then typeform.net, whatever. And they sort of shift between the different services. They find one that's not very good at dealing with abuse and is pretty open, and then hammer it and then move on to the next one. So maybe that's what's happening. I don't know.
Certainly sounds like an area where some data sharing could be very beneficial. And which I guess goes back to one of your first research questions, Thymen, in terms of how you can sort of share learning without sort of sharing the actual underlying data sets in some way. Okay, thank you, Peter.
Eusebio, I have one question.
Fire away, Eusebio.
Yeah, for Thymen. It's very simple. You are showing the results and what do you know with counterfeit websites. Have you an experience with, let's say, in low places that could also have some counterfeit or contents that what to say are not so legal? Or would you just go for the website specific, which is fully devoted to for offering counterfeit?
I'm not sure that I completely understand your question. Can you rephrase it?
Yes, have a look on the streaming site of you know, website that have streaming, that have lawful content, but also because any reason doesn't matter right now here, they may have another which is not legal. So, have you just considered that as a part of the work you've done, or doing, sorry, or it's something that you have not think about yet?
No, we have not think about that yet. No.
Okay, but because applying machine learning, even that not just fully AI, but still machine learning of help. But I'm not really sure how to do that. Just was asking for that. Thank you.
Thank you, Eusebio. Maybe there's a sort of an area for further investigation there then. Okay, does anyone else have any questions or comments? Either sort of raise your hand or put them in the chat if that's easier. I'll just give you a moment to try and do that. Just whilst people are thinking, are you happy to share your slides after the call, Thymen, so make those available?
Yeah, sure. Yeah, we always publish our slides, so that's not a problem. We try to be as open as possible. So yeah, sure.
Yeah, because I think they were pretty content rich today. So I think they'd be well worth people maybe going through at least a second time.
Yeah, sure. And if people have questions, then just drop a line. Yeah.
Yeah, brilliant. Thank you. Right, I'm not seeing any more hands raised or anything in the chat, so I think we've exhausted people's initial comments and questions. But thank you. I think that was fascinating, and as I said earlier, there's a lot there. So I think that will provoke some sort of further interaction after the call, and certainly clearly more areas where machine learning can help make the internet that little bit more secure, which I think we'll all benefit from. So thank you for taking the time. And you, yeah, I thought there was another question, but Mark was just showing his appreciation, which is also good. Thank you for that. Right, well, we'll move on. You are of course welcome to stay for the rest of the call, Thymen, and sort of joining as appropriate. But thank you for taking the effort to sort of go through the presentation. But that does bring us on to any other business for this call. I'll mention, because not everyone gets the UK press, I'm sure that's a gross understatement. There's an interesting article in the one of the Sunday papers yesterday, giving a particular journalistic take on Apple's private relay plans, which I put it in the weekly headlines, but I suspect not everybody has yet seen that. Let me just see if I can pop that on the screen so you'll get a flavour for it, which I probably should have prepared earlier, but I didn't think. So just bear with me. If I share my own screen. I'm hoping you can see that on your devices. I'm not expecting.
Yeah, we can see that. Thanks.
Thanks, Peter. I'm not expecting people to read that quickly whilst it's on the screen. It was more, I think, from the sort of headline and the sort of emphasized text partway down the second column, you'll get a sense of the sort of tone and direction of the article. So I thought that was worth highlighting as that appeared in the press yesterday. I've not seen anything like that in other sort of general as opposed to technical press anywhere, which is why I thought it was worth mentioning, but also just to pose a question I don't know if anybody else has. Because as I say, this is in one of the mainstream papers, the Sunday Telegraph, for those of you that might be interested in the specific paper, rather than in any of the specialist press. If the link is in the sort of the headline email, but if anyone hasn't got that and wants it afterwards, then just let me know and I'll happily share that with you.
Andrew, so at the bottom of that article, it essentially says something about the police will have to ask Apple for information. And Apple says, yes, we'll work productively with requests for evidence. But I didn't think that was actually possible with private relay.
That's rubbish.
It's not, because they only have
so
some
I
of
don't know who's missing the picture there, but it's the way it's designed. Apple will not be able to, will not have any data to be able to say that this user went to this site.
The only thing they can do is tell them which egress relay to go and talk to.
I think it's a case of journalists talking bollocks. Excuse my French.
I think Apple would know that a communication had taken place, if I remember the specifics of private relay, without necessarily without knowing what the content of the communication was. So I suppose it depends what the expectation is as to how Apple may be able to help an investigation. I think they could pinpoint that user X did indeed communicate at a specific time. They couldn't say with whom they communicated, though, so they couldn't match up the records. They could simply show there was some outbound communication, I think.
I don't think they can even do that.
No, it's the other way around.
There's some sort of anonymous ticket that the phone obtains from the ingress or from Apple, and then it redeems those tickets against the ingress relay. So the ingress relay can't know who is contacting it, in theory.
Okay.
Well, hey, so one thought on this is, it's interesting that if you take a step back from what they can do and what they can't do, we've been having this sort of conversation now for quite a long time, right? We've had it around network operators, we've had it around device manufacturers, we've had it around encryption, we've had it around websites, and it's Tony's point about this being an old debate is well taken, but maybe it's an opportunity to once again sort of have a look at, well, what are the sort of the roles here of the various people, not organizations, not functions, but what do we want as an internet community? What is our goal? And we've had one set of goals we've sort of been marching to for the last few years, which is make things harder, make things more encrypted, make things more oblivious, if I can go there. And, you know, maybe it's a question now we need to step back and say, well, we're going down that path. Is that ending up where we want to be? If it's not entirely where we want to be, are there little tweaks and stuff here that we need to consider doing a little bit differently? I don't think we're going to walk the whole thing back, but do we need, like, you know, something? Or maybe we'll, you know, have that discussion and say, well, you know what? Yeah, there's some badness that comes from these things, but it is going where we want to go. And you have to accept the badness and sometimes in some of the good context too. Nothing's perfect. And I think sometimes as engineers, we fall into the category of, but I want it to be perfect. And I want everything to be perfect. And it never is. It just never is.
Yeah.
How are you going to get everybody to agree, though?
You never will.
On what you want.
You never will get everybody to agree, right? But in the end, I think, and I know that internet people don't like this, but in the end, you know, it's an amalgamation of what we do as tech leaders and what we build as tools that can be used, but also where the policy space goes and where the politicians go with the legislation. Right? It's this ultimate amalgamation. And I, you know, like many of you, I've been at this a few years, and I can remember back, way back, you know, back into the 90s, or even before the 90s, when we talked about, you know, is hacking even illegal? Is that something you can be prosecuted for? And in some places, it wasn't. and we had a lot of policy conversations through the years that evolved. And I think that's, you know, we're here doing the same thing again. And I guess my one observation, having done this for all these years, is continuing the conversation is maybe the most important part, right? Having these calls like what Andrew sets up, but also when we meet in person and we have conversations in the hallway and we have broader talks, that I think is the most essential thing. Is if we were treating the camps where we simply issue a statement, say, we think it should be X, Y, Z, and I'm not going to listen to any other conversation, that's when we sort of lose the momentum of making things progress. We won't always get what we want, but, you know, as they say, maybe we'll get what we need.
Yeah, I think that's a fair comment, because I think at the moment there's sort of common position of the industry such that it is would the nearest thing to that would be the policy as sort of stated by the Internet Society and the ITF around end-to-end encryption is the nearest to coherent policy. But I guess what you're sort of highlighting, Glenn, is that, you know, perhaps every so often that needs to be examined, because, as you say, the industry doesn't operate in a vacuum, and the other stakeholders, like the politicians, may at some point intervene with a different answer.
And examine doesn't always mean that we step back and say, oh gosh, we've done the wrong thing, we need to change course. Sometimes it just means we step back and go, yeah, it's not perfect, but did we end up where we were trying to go to? Yeah, we did. And we can then, you know, put into context what we've decided. I mean, the reality is bad guys are going to use encryption. The reality is bad guys have been using encryption for a lot of years. And you know, good guys are using encryption too. I guess I've become, you know, a little less black and white in my thinking over time. And it's sort of like a football moving up and down the field.
Yeah, yes, indeed. Peter, you've raised your hand.
So yeah, I just had a quick question. Chris, you said that it's not possible for Apple to ask for the information, but would it be possible for something like what happened with Proton Mail, where they, either Apple or another company, had to enable logging or had to add that? I'm not familiar enough with the design of the Apple Private Relay to know if that's even technically possible.
You have to collude. The only way Apple can find out is if they collude with an egress.
So if law enforcement got those two companies to force them to add logging, that's one possible.
So certainly the way Apple have described Private Relay, yeah, it's designed to frustrate any attempt to request information. Yeah, I mean, the general basis of it, yes, is you require collusion, but on top of requiring collusion, i.e. between ingress and egress, you also require, in the case of private relay, you require some modification to the way in which an IOS client is authenticated against the ingress, because the ingress doesn't just allow just anybody to connect. It says you need to have this token. It needs to be valid. So clearly it's within Apple's power to make changes to how it works, but the way it's been described, yeah, it would need significant modifications to enable such a data collection.
Yeah, I'm presuming it would be quite a pain. Someone would have to manually go through IP port time maps to egress IP port time, and egress would then have to do exactly the same thing.
Yeah, which, given the volumes, could be quite
it could could be quite painful and slow.
I should highlight, because Pat's rather helpfully put in the chat, that there is, or there was, it may have been fixed now because there was an update on iOS 15 in the last couple of days, but there was a vulnerability about JavaScript leaking the hidden IP, which is, and he's helpfully posted a link to that, which some of you may or may not have seen. So there may be a method.
Andrew, Arnaud here. Just a question for clarification. The Apple Privacy Relay is only for residential market. I mean, is it right to say that Apple is not enforcing this for enterprises?
Well, it's disabled, not disabled, sorry, it's switched off by default. But as I understand it, anyone with an iOS 15, iPad OS 15, forgot the name of the Mac OS that mirrors it, that has iCloud Plus, an iCloud Plus subscription, can use Private Relay. So I don't think that excludes.
Well, Apple have excluded any client that is a managed device or has a profile installed, or a particular type of profile. Yes. Yeah, like a educational device or a corporate device.
Yeah.
Presumably, though, the people who manage that device could use their management system to turn it back on, though.
Presumably, yes.
Yeah.
Yeah, there's also, if you take a look, they've also published 2 canary domains that if the network exposes them and does an NX domain response in the DNS that the device is using, it will essentially pop up a message saying, hey, this network doesn't support this Apple Private Relay use.
Yeah. So I guess to your early observation, Glenn, about politicians and law enforcement, etc., to sort of generalize that slightly, if in a given country they decided that the issues posed by Private Relay were unacceptable, they could require network operators to use those canary domains. So it wasn't a viable option in that particular country.
Or they could require Apple to turn it off.
Yeah, I mean, it doesn't really block it. What it does is that it sort of pops up that message. You can bypass it by changing, ironically, your DNS provider. I mean, probably familiar to a lot of people on this call that notion of switch your DNS.
Yeah, fair enough.
Well, we've already got the list of countries where it's not launching. Yeah, and I'm guessing that's because the governments of the countries concerned have made it very clear to Apple that they will not allow it.
I think it's fair to say those countries have a fairly, let's call it, robust approach.
Yes.
And you possibly wouldn't want to be on the wrong side of that.
No.
Yeah, Glenn, you raised your hand. Was that what you wanted to say, or did you have something else to say before I go?
It was. Sorry, I should have lowered it.
That's okay. Thank you. Eusebio, you wanted to come in as well.
Yeah, I just wanted to make a comment. There's only one end in this communication through the Apple Private Relay. Who knows all the information, which is the device. That's all. I mean, whatever you want to find in the way that is very well designed in order to hide information or to make it possible to pair destinations and origins, it's all included or I would say, in clear on the device.
Yes, yes.
No more words on that.
Yeah, fair point. You could always go to the device, which again, you would need Apple's cooperation at that point. Okay, well, that was just, I thought it was just going to be a brief aside, but I think that was a useful discussion. Well, our hour is up, but was there anything else that anyone else wanted to raise before we finish the call?
Yeah, I can't raise my hand at the moment for some reason, so I just speak. There are two things. So I just kind of in the background confirmed that the JavaScript bug is not working with Monterey, the Mac OS, and that they also confirmed that from the sort of developer of the fix. So I guess this will be fixed in iOS at some point also. I wasn't able to attend the last couple of calls, and I actually listened to the recordings today. And from last week, there was a very interesting discussion about how you kind of potentially can block or identify DOE traffic. And the one thing on that talk, and I'll probably also post it to the email list, is what the example in the talk given wasn't actually DOE at all. It was kind of like a version that Cloudflare and possibly also Google did before the DOE RFC actually came out. Because the DOE RFC is just use a plain DNS packet, stuff it sort of in the HTTP request and send it to the server. And what they have was more like a JSON type. Okay, QName equals www.google.com and Q type equals. This is not DOE. And I've been kind of professionally been too often on the side that I have to explain to people that this is not DOE. Because it is not. It is kind of like a JSON type protocol that Google and or Cloudflare did. So just wanted to point that out, and I'll probably write something to the mailing list with regards to that also.
In which case, that was a good spot, which clearly passed us by on the conversation last week, Ralph. So thank you for highlighting that. And yes, please do post something, because I know that our two sort of researchers will find that quite helpful. So thank you for the point. Right. Well, on that note, we've sort of finished the call there. I have reached out to Google since last week, and I'm trying to get one of the Android team to come on the call in the next week or so to talk about the plans to support DOE within Android 13, Tiramisu. If anyone has any leverage with the Android team that wants to encourage them to do that, that'd be much appreciated. And hopefully we can get them on the call to sort of just expand on their sort of plans, how it's going to work, whether it will fail open, fail closed, all those sorts of good questions. And what I will do, I think I'll put out an email separately to ask people to start to think about any questions you may wish to ask. In anticipation, we did get a volunteer from the Android team onto the call, just to make sure it's as productive a discussion as possible. But with that in mind, we're slightly over time, so apologies for running over. I think it was an interesting call. So thanks everyone for your time this week. Have a fantastic week, and speak to you same time next week. So thanks all.